Okay, so this is the second video in which I will tell you how to generate the wave function when a particle is in an infinite potential well. So let's create a file. Okay, so I will tell you everything in this video which I missed in the previous video. So this is the way to write a Fortran code. This is first line I am defining the program whose name is main. You can type whatever you want. You can give any name you want to give. In the second line, implicit real star rate a to h o to z means we will take the numbers in double precision, and a to h and o to z, the whichever words which are starting from a to h and o to z behave like real numbers, and in between numbers will behave like integers. Okay, so I'm just starting it. Okay, so first we have to define what are the functions which we have to use. I haven't defined the arguments yet. Again, implicit real star rate and we have to define the function again. I hope you can see clearly. If you find anything difficult, you can just tell me in the comment section. I'll try to solve the problem as soon as possible. I hope this code works because even I don't know whether this gonna work or not. As I told you, my supervisor always says write a single line and check whether it's working or not. Otherwise, you won't be able to tell that you are suffering from a problem. Okay. So you know the Schrodinger equation is a second order differential equations which we can break into two first order differential equations. So first function will be z2 and the second function will be, you have to break down by yourself. I will tell you in the description then how you can break a Schrodinger equation into two differential equations. I'm defining R mass, energy by EPS, and psi by Z1, and Z2 is d psi 1 by dt. Sorry, dx. Okay, so first we have to define the parameters. What is the value of R mass? It's 938.2. Here d0 means we are taking the number in double precisions, and these are in nuclear dimensions. Okay, so far so good. I think we can check. So we have to define the arguments. Argument will be x, what is the dimension of the box, z1 which is psi, z2 which is the derivative of psi, and EPS, energy, which we have to find. Okay, the same argument will be given here, one z2 and EPS. Okay, so the thing is that now we have to define some parameters. What is the value of psi is equal to, psi starts at 0 because at boundary at x is equal to 0, psi is equal to 0, and dp and the derivative of wave function, it should be 0, but we are not taking it 0, we are taking it as a small number. Okay, so okay, and the other thing is that let's take the number of iteration npts 1000. Okay, So there's one thing I forgot to tell you. You know, in the previous video, we find out the states and the energy eigenvalues. So the thing is that I saved these values in state energy.txt file. Okay, you can see the values are saved inside these text files. So I am calling these text file inside the wave function file. I am opening the file. You can give it the unit like 55. I hope it's work. There are so many things actually. Then you have to read the file. You can see we have the 6 values: state 1, state 2, state 3, state 4, state 5 and state 6. So do I is equal to 1, 6 with the difference of 1. Read the file 55. And the energy value. Okay, so first we will check whether our program is able to read the previous file or not. So as you can see, nstate and energy are in the form of array, so we have to define the dimension of array. This is a similar single way, like the way I know to define an array. There are so many other ways which are more efficient than these one, like allocatable, deallocatable, which I'm not much familiar with them. Okay, and we have to define the parameters. Okay, let's take the dimension is 5000. Okay, okay, so far so good. So first we will check that whether it's working or not. I hope it should work because there should be no error, but let's see. Yeah, okay, so our file is able to read the states and their corresponding energy values. So the thing is that how would you find the wave functions? So the simple solution is, you know that what is the value of energy in a particular state, so you just have to put the value of these energies in these functions and find out what is the value of j1, how the value of j1 varies with x. Okay, so that's what we're gonna do now. Okay, so let's see. So for this we need Rangekota method. So here I'm not going to write Rangekota method, so I'm just copying it. This is my own Rangekota method, so don't worry, I will explain you that how it's written. Okay, so okay, I have defined npts. So the other thing is that we have to define what is the initial value of z1 is it will be shy, and z2. Right, so now they are also in an array, so we have to define an array. Okay, so far so good, I think so. Okay, so might be able you are in between the video you are listening the sound of ding ding ding. It's actually a Ubuntu system, so yeah, whenever it struck somewhere or the cursor hits somewhere, it makes the sound of ding 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 ding. I like that sound actually, so I'm not turning it off. Okay, so here I'm defining the dimensions of the parameters which I'm using. Okay, again ding. There are so many other things we can talk about, you know that. Okay, so have you heard about Schrodinger's famous cat experiment? That's a really cool experiment in that we know that there is a 50% chances that we can either save Schrodinger's cat or not. But recent studies in 2018, there is a paper in Nature which shows that if we observe our system very much carefully, then we can save the Schrodinger's cat. If you love cat, then that's a good news for you. Okay, so far so good. So now the other thing is that we have to define what is the value of first we have to define a dimension like 10. So our box, the dimension of box will be start with -10 femtometer and end point, we know that its final point npts is equal to plus r. So what will be the value of h? H means what is the value of step by which we are going to solve Runge-Kutta method. Okay, so I think so far so good. So the thing is that we have find out the energy values, right? So I don't know whether I'm doing it correct or not, but yeah, I hope so that we are good. Okay, so now the thing is that I have to put the value of energy and EPS is equal to n dot I star 1.0. so to make it a real number, all right, there is no problem. You can also take EPS is equal to energy, right? We won't be in a trouble. Okay, so this is the Runge-Kutta method. I'm not using an array for EPS because we have to put a finite value of energy at first point. Like when I use I is equal to 1, it will take first value of energy, which is I think 0.512 MeV. So it will first put 0.512 MeV and start the iterations for x is equal to -10 femtometer plus 10 femtometer and find out the value of wave functions. Okay, so I will also put this code in the description. You can copy paste it also. Okay, I hope I am not getting any error right now. I'm not sure whether this is gonna work or not. First I have to check that whether I'm getting any kind of error or not. So okay, I have defined x1 also, I have defined z1 also, I have defined z2 also, I have defined energy also. So I won't get any error, I hope so. But okay, pointer attribute, I haven't defined the dimension of x actually. Okay, z1 z2 is defined, but I haven't defined the dimensions of x. Okay, so we are now error free. so you don't need to write it's correct. Okay, so the thing is that the wave function is defined by psi, so we are just about to find the value of what is the value of z1. Okay, and how the z1 is changing with respect to n. So I hope that's gonna work, but let's save that into a file of, just assume like 567 number file. So we have a file 567. Let's try to plot. So we are diverging somewhere, so I don't know where I'm missing the point, but it should have worked actually. I don't know, but it's working from x is equal to, I don't know, let me check whether I'm taking a correct value of things or not. X1 is equal to r lambda ts minus x1. Okay, there is a mistake. It should be npts. Yeah. Oh, so bad. so bad. Okay, I got it, I think. I don't know where I'm missing my point, but I is equal to 1 to n x and z1, and it should have worked, but I don't know why I'm missing the things. Okay, let me check my previous code. So this is it, 99 z1. I'm sure that I'm not making any kind of problem. z1 x1 npts x npts equal to plus r lambda npts is equal to psi is equal to 0. I hope it should have worked actually. Minus 2.0 z1 divided by h bar square. I don't know why I'm missing the point. EPS is here. I'm using EPS star 1.0, n is equal to 1 comma npts is equal to 1000. Previous results were far better than this one, but I remember, I don't know where I'm missing the link, but okay. Okay, so this is the code written by me. I'm trying to solve it by this one. Okay, so the file is okay. So these are the wave function. As you can see, n is equal to 1. This is our first wave function. N is equal to 2. This is our second wave function, and so on. Okay, so I know I made a mistake during my original code which I'm writing, but this is the code written by me. Okay, so I will upload this in description. If you need any help, or if you are unable to understand anything, then please let me know. Okay, thank you very much.